for my favorite way of solving systems of equations, and that is elimination. So, just to be clear, we are still solving systems of equations. That is, we're giving two equations, and we're looking for that ordered pair that is the common solution to both equations. First day, we graph them to find that point of intersection. The next method was substitution, when we were substituting in for one of the variables in the other equation. But then today, as I said, is my favorite way, and that is elimination. Now, elimination works, now the instructions are here, but we'll walk through the one example, is when, again, we need to combine these equations somehow, and we're going to combine them by adding them together. So we're going to be adding these equations together, but what we want to happen is what's going to happen on this first one here is that when we add these equations together, we want one of the variables to eliminate. And so notice here, if we went to add these two equations together right now, see how the x terms would cancel out, because 4x minus 4x is 0, and they cancel each other out. So that's exactly what we want to happen. So if those cancel out, we continue on, and we get 16y equals 16. Dividing both sides by 16, y equals 1. Isn't this fabulous? It's so great. Now that we found y, we need to find x. So I'm going to erase that for now. And I'm going to look at this first equation, and I'm going to plug back in 1 for y to solve for x. So that gives me 4x plus 9 equals 5. Subtract 9 from both sides. 4x equals negative 4. X equals negative 1. And so my solution is negative 1, 1. If I wanted to check it, okay, to check it, I would use the other equation, not the one we used to solve for x, but the other one. So negative 4 times negative 1 plus 7 times 1, does that equal 11? Well, that's going to be 4 plus 7. Yes, we get the right answer. Now, for my second example here, for number B, notice if we add these together right now, nothing will cancel out. But this right here is close. If only one of them was negative, we would be all set. Well, let's keep the first equation the same. But now let's multiply everything in the second equation by negative 1, which would make it negative 2x minus 2y equals negative 18. See, by multiplying everything in the second equation by negative 1, and that is everything, now my y's will cancel out when I add them together. And that's going to leave me with 2x equals negative 12. Dividing both sides by 2, x equals negative 6. So even though we're solving these algebraically, notice we are still getting nice answers, okay? So if you get a decimal or a fraction, you probably went wrong somewhere. Now that we know that x equals negative 6, we can take either equation. I'm just going to take the first one. And we're going to find y now. So negative 24 plus 2y equals 6. I'm going to add 24 to both sides. That gives me 2y equals 30. Dividing both sides by 2, y equals 15. So negative 6, 15 is my answer. That's kind of some big numbers there. I want to check it. So to check it, I'm going to plug into this second equation. So 2 times negative 6 plus 2 times 15, does that equal 18? Well, negative 12 plus 30, oops, not negative, but we get 18 equals 18. Yep, it does check out. Okay, here's one for you to try. Notice right now It's very nice, right? See how these x's cancel out? 5y equals 10. Y equals 2. I'm going to plug back into the first one. Oops, equals. So x plus 8 equals 13 minus 8 minus 8. X equals 5. So 5, 2 is my answer. To check it, you would check with this other equation. So the opposite of 5 plus 2 equals negative 3. Negative 5 plus 2 equals negative 3. Check. All right, last one. Last one. Oh, nothing cancels out. However, if only this right here was negative 2x, then we would be all set. That would be the easier one to solve. Well, we can do that if we multiply everything by negative 2. So we're going to multiply everything in that first equation by negative 2, which is going to give me negative 2x minus 6y equals negative 12. And then I'm going to rewrite my second equation right underneath it. X's cancel out. Negative 13y equals negative 13. Y equals 1. Now that we have that, we can plug that back in. I'm going to plug it in the first equation. So x plus 3 times 1 equals 6. X plus 3 equals 6. Minus 3, x equals 3. So 3, 1 is my solution. To check, I'm going to use the second equation. So 2 times 3 minus 7 times 1 equals negative 1. 6 minus 7 equals negative, 1. 1, check. Oh, we're not done yet. We got 2 more because they can get more interesting. So let's see. Oh, that was C. Okay, so for D, to get rid of, probably the easiest would be to get rid of the x, because we can easily make them both into 8 versus we would have to do 2 things to get rid of the y. So I'm going to multiply this whole second equation by negative 2, which is going to give me 8x minus 5y equals 11, and negative 8x plus 6y equals negative 10. Those cross out. Y equals 1. Now I'm going to use the first equation. 8x minus 5 times 1 equals 11. 8x minus 5 equals 11. Adding 5 to both sides. 8x equals 16. X equals 2. So 2, 1 is my solution. Check. 4 times 2 minus 3 times 1. Does that equal 5? 8 minus 3 equals 5. Check. I love this. I hope there's lots of 100% on our next quiz because you can check your answers. All right, so this one, we could eliminate this one right here. We could eliminate x or y just as easily. If we multiply this whole thing by negative 2, we can get rid of x's. If we multiply the whole thing by negative 7, we can get rid of the y's. I think most of you will probably pick multiply everything by negative 2, only because the x is first and it results in smaller numbers. So when we add them together now, the x's cancel out and we get 5y equals 5, y equals 1. Now I'm going to plug back, in to the first equation, and x equals 1. So 1, 1 is our answer. To check it, I'm going to use the second equation, the one we did not use. 2 plus 7 equals 9. Check. And there you go, my favorite method, elimination.